Let's give him a warm round of applause.
Good afternoon, everyone. 8 years ago, my friend made a prophetic comment saying, the future doctors are going to be mathematicians. Now, today I see the truth in those words more clearly than ever. I see a lot of mathematicians interested in healthcare technologies, improving technology for personalized patient care. Consider this, cardiovascular disease is affecting 25% of the adults worldwide, and in India, CVD is the leading cause of death. The statistics are very staggering. As of 2017, 26.6% of all the deaths in India were due to CVD-related disease, and which is up from 15.2% in the 1990s. This is a graph showing the trend from 1990 to 2018. This is from a World Health Report of 2023. So for many years, medical professionals have relied on electrocardiogram, the ECG, as a fundamental tool for tracing cardiac electrical activity. Hypertension is one of the major risk factors in health, so heart-related conditions. And assessing hypertension using traditional clinical approaches have many challenges if we just rely on sphygmomanometer or what we call a BP curve. However, we are now moving beyond this traditional methods to more sophisticated diagnostics that include genetic variation, echocardiography, and biomedical markers like NT-proBNP, which is complemented by treatments like CABG or angioplasty. Now, these tools help us make better preliminary diagnosis, implement standard operating procedures across districts or even states, which reflects upon how far we have come in integrating these technologies into our healthcare. Here's a heat map that illustrates the correlation between various biomarkers from this analysis involving 216 patients over a period of 9 months. And in this analysis, we see the key biomarkers like genetic variations or echo and NT-proBNP and angioplasty, how statistically significant they are, significant relations that they have between each other. Now, this indicates that they are potentially interrelated and they provide valuable insights into patient diagnostics and treatment planning. In order to address the imbalance in our dataset, we did SWOT analysis, which is synthetic minority oversampling technique, and which enables the representation of minority classes in our dataset. Now let's consider how genetic variation is closely linked to factors like race, ethnicity, and geographic origin. How it plays a major role in medical diagnostics. Take for example 2 individuals, Raj, a 45-year software engineer from urban India, and John, a 48-year-old executive from suburban California. According to the World Health Organization data, Raj has a 0.31% probability of having an ischemic heart disease, and John has 0.09% chance, which indicates how demographic influences are there on health risk. But what are the chances that Raj or John would voluntarily undergo an ECG test or actively seek heart disease diagnosis? Practically speaking, they might prefer not to, and in many cases it might not even be necessary, because imagine everyone reading something online about a cardiac disease or any statistics like this, wanting to get an ECG done, heart diagnosis done. So we need non-invasive methods to do preliminary checks rather than traditional approaches or invasive methods. And imagine instead we use statistics like data from WHO, and we do preliminary checks using data from variable smart devices, and running this data through deep learning models, we can run diagnostics quickly and effectively, providing personalized insights without the need for traditional and more invasive testing methods. Now, alternatively, even starting with simpler machine learning approach, such as random forest classifier, because of its simplicity and requirement of less database. A decision tree classifier, ensemble learning to evaluate the data, making it a robust tool for preliminary diagnosis. So this is how we integrate to transform healthcare delivery, making it not only more efficient, but also more accessible and tailored to individual needs. Contrastingly, a neural network approach in deep learning would involve more layers of interconnected nodes. I'm sure many of fellow speakers have already talked about how neural networks can help, how deep learning can be beneficial when you have huge amounts of data. However, unlike random forest, like I said, neural networks require substantial amount of data, which I think Dr. Manju also pointed out in a talk that collecting data and processing the data is a huge challenge. And due to limitations and also the computational compatibilities, a random forest might be a better approach if you're just focusing on a preliminary diagnosis. And again, it depends on what is the purpose that we're looking. Now, I'll just tell you a brief story about the World War. A mathematician was asked during the World War, saying many of the planes are getting shot at certain areas of the plane. And a mathematician was asked to analyze how to better design the plane's defense mechanism so that those areas where the bullets were hit is safeguarded. Imagine what the mathematician answered. He said, "So we should concentrate on those areas where the bullet is not hit, because those are the possible planes that are not turning back." So as a mathematician, asking the right question and setting the right problem statement would matter even before beginning to solve that problem. Now that we have identified that data is required in huge amounts of data, in huge amounts of volume, we would need to address the challenge of data collection and processing. The modern ECG care units generate huge amounts of ECG signals from bedside monitors, or even if you consider connecting smart wearable devices and all. And most of the researches online that we've seen are being done on single-LED or dual-LED monitors. And only recently that we are seeing more and more research coming on 12-LED ECG data. And the largest data set that I know of is the PTXP dataset, which is open source, available on the internet. The only challenge is that PTXP dataset is for the patients, 21,000 patients, taken from 1990 to 1997. Now you know that from 97 we already come almost 28, 30 years, and training a deep learning model on those data sets, on that data set, would not be a great choice right now because of the lifestyle changes and a lot of work-related stress and all that we need to accommodate in our deep learning model. So, to preserve the integrated details that are captured in these 12-lead ECG monitors and also use the cardiologist annotations into it, we need to use a format which is something I would suggest an HDF5 format, which is greatly beneficial because of its hierarchical structure. It's ideally suited for handling, storing, and updating and sharing large, high-resolution data sets. And this is also a great choice because of its compatibility across platforms. So starting from open source platforms like R, MATLAB, and R and Python, and to more commercial applications like MATLAB or Ideal, HDF5 file format is compatible, and also because it is hierarchical, you can have like a folder structure inside a single file. Of course, processing these files are a challenge, but you will have a lot of help from communities like MATLAB and all that. And here you can actually add metadata. You can have annotations from cardiologists, keep on adding them, like update more parameters to include smart device data and all that. So given the scope of discussion and also because we're already running out of time, so I'll refrain from delving deep into the technicalities of the HDF file format. But the point that I would like to make is the significance in using HDF5 file format in storing, processing, or analyzing this high definition full waveform data, which is generated by an ECG bedside monitors and all the other devices that we're going to use, both invasive and non-invasive techniques. Now let me illustrate how all this can be brought up into one single environment through an illustration, for example. Let's take a practical application of these technologies. So Dr. Priya Mehta is a seasoned cardiologist who has a clinic in Mumbai. She has outfitted a clinic with the latest deep learning algorithm and IoT, Internet of Medical Things. So today she is scheduled to meet Mr. Rajan, who is a 52-year-old, Rajan Gupta, who is a 52-year-old man, and she is reviewing the medical history of Rajan. And she is reviewing the symptoms of Rajan, and he was referred to Dr. Mehta for fluctuating blood pressure levels. So this had puzzled Dr. Rajan's general practice because of the varying BP levels, and Rajan explains that he feels fine most of the times, but occasionally experiences severe headaches and fatigue. Now his BPs have sometimes shown elevated readings when he measures his BP at his home, but during his normal visits to doctor, his readings are very normal. So with her experience, Dr. Mehta understood that this is a case of a masked hypertension, where BP spikes intermittently, but it is hard to diagnose with conventional methods. So Dr. Mehta decides to leverage her clinic's advanced capabilities. So she begins explaining to Mr. Rajan saying, she's going to use some cutting-edge technology and fit him with a measuring device, a smart device, which can help her monitor the blood pressure and the ECG of Mr. Rajan over an extended period of time during his regular work, his office time, his sleep time, and all that. But this device that is fitted, that Rajan is fitted with, is connected in real time to the deep learning model which Dr. Mehta has set up in our clinic. And this deep learning model is trained to recognize patterns that are indicative of hypertension parameters and even to identify potential triggers that are in Rajan's daily routine. So as the days pass, the model collects data and analyzes the incoming data, noting that there are several episodes of high BP and particularly Rajan's high stress meetings at work and his work stress related parameters, and then the late in the evenings. So the deep learning model, it correlates these spikes with simultaneous increase in heart rate, and it also the decreased physical activity. So algorithm back at the Dr. Mehta's office, it paints a clear picture of Dr. Rajan's conditions when hypertension occurs, when hypertension emerges, and it generates a comprehensive report which Dr. Mehta can review. She reviews the report, she notes the algorithm's observation on potential stress-related triggers and evening spikes, which are probably linked to his dietary conditions, dietary habits. So with this information, Dr. Mehta schedules a follow-up meet with Mr. Rajan, and she discusses the findings. She suggests some lifestyle changes, lifestyle modifications, medications, and to manage his conditions effectively. Now the main aspect of this is we are keeping deep learning model as the engine and keeping the cardiologist as the driver. So we are putting the cardiologist as the driver's seat rather than replacing a cardiologist, because you always need an expert in the subject matter to be reviewing, correcting, and annotating the deep learning model, which also every annotation that Dr. Mehta writes, every statements, ECG statements, is feeded back to the deep learning model through a high definition image scanner and an OCR. So now, after the follow-up consultation, Dr. Mehta also introduces Dr. Rajan to the wearable app, the wearable device with an app which is connected to the deep learning model. So now we have a network where the wearable device is owned by the patient, we have the deep learning model at the doctor's clinic, and we have an app which the patients can use, and the app is generating real-time prompts to the patients which they can get reminders to meditate, exercise, or avoid certain foods. So once this app, wearable device, all that is given to the patient, and Mr. Rajan is aware of his condition, how to better handle his healthcare, his hypertension. He is satisfied that he now gets more control. He gets a sense of more control over his health. Now, when he lives, he is satisfied that whatever that Dr. Mehta had set up has helped him, and he can also time to time remind him to take certain actions. And on the other side, Dr. Mehta also feels satisfied that this process has helped the patient to give a personalized care, and she goes ahead and shares her observations on a cardiologist network app, which is completely decluttered from the regular social network, because you have very focused set of people reviewing your work, giving you suggestions, seeing your work, and all that. So she emphasizes the role that hierarchy and deep learning has played in diagnosing and managing the masked hypertension of Dr. Rajan. She posts a case study. Shortly after the post goes live, it catches the attention of Dr. Emilia, who is a cardiologist from Hungary. So impressed by this outcome, Dr. Emily reaches out to Dr. Mehta, asking her, showing her interest in setting up a similar setup in her clinic in Budapest. So Dr. Mehta is thrilled to assist, so they began coordinating, and she shares insights on specific technologies, vendor insights, vendor details, IoT devices, and tips to train the deep learning model on with the local patient data. So this is where the geographical, the demographic background, the geographical presence, the race, ethnicity, all that comes into picture. So they discuss various implementation challenges, and they work on customizing the deep learning model. They're not reinventing the deep learning, they're not recreating or designing a new model. They're only doing fine-tune of few hyperparameters. So the base parameters are the same. They're fine-tuning with the race, the genetic variations, and all that. And they customize it to Dr. Emily's practice environment. So now that we have a complete network, so there is one cardiologist who has set up a process, an operating procedure. It is shared through a network, and some other cardiologists from a different part of the world is interested. They collaborate and they make one full cycle wherein you have we are working on bringing up a standard operating procedure. You can share data across. So you might have known some of the schools, for example, for especially the people working in central government jobs, there are schools that follow the same syllabus across the country, India-wide, at the same point of time. The same chapter is going on in every other class. So if a central government employee is transferred from Bangalore to Mumbai or to Delhi, the student does not need to adopt to the new syllabus that is, or the different syllabus that is being taught, the different chapter is being taught. So likewise, setting up a standard operating procedure for cardiac care ensures that there is a standard operating procedures across. And of course, this is a very long shot, but we can reach there slowly, wherein you can be able to deliver the same personalized care irrespective of the geographical location where you are getting diagnosed. Let me summarize the points. Incorporating genetic diversity into cardiac care is crucial for advanced precision medicine. By acknowledging and understanding the variations in genetic predispositions across the demographic groups, cardiologists can tailor treatments and develop prevention strategies to individual needs. The integration of tools like SDF file formats for data collection can help us better handle the data processes and data collection, pre-processing analysis of data. However, without neglecting, these advancements should be taken into consideration with an ethical point of view as well. There should be an ethical committee who is reviewing the ethical consideration in the data collection. There should be a statistical committee which evaluates the standard of procedure, because there's something called a tripod technique which ensures that a process is applicable in a healthcare setup, in a clinical setup. So having a network, you might be able to connect to some. I heard Dr. Pallavu asking question about how is it licensed by a community stands, and so those kind of things can be taken better, done in a better way if we have all in a single decluttered network connected across different geographies, across cardiologists, statisticians, engineers, and industries. So we will be able to set one standard which is applicable in healthcare, research and industry all together, only if we are able to bring all that into one single chain of, one single cycle of process. So that's it from my end. Thank you everyone for your time, and if any questions I would like to take. Thank you.
Thank you, Mr. Xavier Prathap, for sharing